Hi, everyone. Happy Friday or Saturday, depending on where you are. Welcome to today's session on artificial intelligence and machine learning for the QA industry as part of the Better Data for Better App series hosted by HeadSpin and Women in Big Data. My name is Sharon here at HeadSpin, and I just want to thank you all for joining us here today. Pretty soon, I'll be introducing Shuchi Rana from HeadSpin and Women in Big Data and our expert speaker, Jonathan Lips. But first, for those who are new to HeadSpin, I want to start with a quick intro on who we are and what we do. HeadSpin is the world's first digital experience AI platform that combines cloud-hosted and on-prem global device infrastructure, test automation, and ML-driven performance and quality of experience analytics for mobile, web, audio, and video. HeadSpin empowers engineering, QA, operations, and product teams to assure optimal digital experiences across delivery channels throughout the development lifecycle. And with that, I'll be handing things over to Shuchi.
Thanks, Sharon. Let me share my screen real quick. If you can confirm you see it?
Yep, looks great.
Awesome, great. Well, thank you everyone for joining us. My name is Shuchi, and I'm one of the co-directors for the Silicon Valley chapter for Women in Big Data. I am also a part of HeadSpin. I'm excited to have my colleague Jonathan talk about an important topic today. So just a few housekeeping rules. If you are not speaking, make sure keep yourself muted, and we'll have the Q&A at the end of the presentation. We will also follow up with a blog, and the video to the link will be posted on our website in about a week or so. Who are we? Our mission is to champion the success of women in big data careers, which includes data engineers, data scientists, data virtualization engineers, marketing, sales, and business roles through training both technical and business skills. And we enable a lot of industry and peer-to-peer learning through our events. I would say we host an average of about 4 to 8 events every month. We were small. We've been around for about 5 years, and we've grown from, I would say, 15 people to now almost about 17,000 women on 6 different continents. So we're excited, and I'm super excited to be a part of this organization. These are some of our key partners that power a lot of our learning. And today's session, as Sharon mentioned, is on AI and ML for the QA industry. And my colleague, Jonathan, will be taking over shortly. So thank you again for joining us. And a little about Jonathan. Jonathan has been a part of, he's been a developer, I guess, an entrepreneurial software developer by career with an academic background in philosophy, linguistics, and theology. And he is the project lead maintainer and one of the architects for Appium, which I'm sure a lot of you know is an open source test automation framework. He is also the director for learning and education programs at HeadSpin. And I'm super excited to hear Jonathan speak today. And when he's not doing all those things, you can find him writing on philosophy of technology and making music. So thank you, Jonathan, for being here. You can find Jonathan online on LinkedIn or Twitter. And you can find us. There's different ways to engage with us. You can, of course, join the organization, be a member, you can volunteer, partner, or be a sponsor. There's a lot of content available online, so feel free to look us up on our website, join the LinkedIn group, Facebook group. We also have a private LinkedIn group called Women in Big Data. So that's a great way to engage with the community, and follow us on Instagram. And all the content, all the videos from our experts can also be found on our YouTube channel. So feel free to subscribe. With that, thank you again for joining us. I'm going to hand it back to Sharon, and I'm going to stop sharing. All righty, over to you, Sharon.
I think we can go ahead and get started. with the presentation. If
Cool.
you're all
Right.
set, Jonathan.
Let's do that. Hi, everyone. Thanks a lot, Shuchi, for introducing me, and thanks, Sharon, for introducing HeadSpin and hosting this webinar. I'm really excited to talk to everyone here today. And I'll go ahead and share my screen now so we can get going with some slides that I've prepared here. Great. So yeah, as Shuchi mentioned, I think this is a pretty interesting topic that kind of marries two things that I'm fairly interested in. Been working in what we call the QA industry for some time now. Took a bit of a different path to get into it than most. Been working on essentially software tools for the QA industry, and obviously, I think we're all quite curious about artificial intelligence, machine learning, the kind of promise it holds for various industries. And we might not have thought, depending on where you come from, might not have thought about what some of the applications of machine learning are for the QA industry. And kind of the focus on this talk will be to give a little bit of an introduction to the way I think about AI and machine learning, which might be quite basic for some of you who may have gone even much deeper into that, understanding that field than I have. But since I'm not assuming we're all coming from the same place, we'll give a little introduction to AI and machine learning so that we can take a look at what some of the products that have been marketed to the QA industry about AI and machine learning have been, and from perspective of knowledge of machine learning, try and evaluate that to say what sort of myth or marketing fluff versus what are some, I think, real interesting applications of these tools and processes to the QA industry. And of course, we'll have some time for Q&A at the end. Shuchi already introduced me, so I don't think I need to spend more time doing that, apart from saying that the kind of three main things that I'm working on right now from a technical and business perspective are this tool called Appium, which facilitates the automation of applications. Basically, it gives developers or QA engineers the ability to write automated steps for any kind of application, which is a key component of the process of automated testing of applications. And at HeadSpin, I'm in charge of something called HeadSpin University, where our mission is to provide great learning content for the QA industry and related industries. So I'll share a little bit about kind of our first big course that we launched towards the end of this presentation. And I also spend a lot of time writing kind of free newsletters and blogs about Appium and mobile app automation and things like that at a website called Appium Pro, which you can also check out if you're curious about that world of mobile test automation. So let's first just quickly define a few of the interesting things about the QA industry, because also many of you might be coming from other parts of the software development world and might not have thought too much about what QA for software looks like. Just very briefly, if we think about the software development cycle as consisting of basically these different stages. Obviously, you can get a lot more detailed with trying to draw diagrams of the software development cycle, but at the very least, we have stages that include coming up with ideas, things to build with software, products, or tools, whatever. There's obviously a stage of actually building things out, and there's a stage of testing the things that you built before you ship them to your users to make sure that they're actually going to work the way you intend. Then there's a phase of releasing the application, which obviously in the old days would have been a long phase of pressing CDs or writing floppy disks and mailing them to people, and now involves pushing new code to a website or pushing new code to an app store for review, things like that. And then we have a stage of figuring out whether the thing we built is actually doing what we intended. And this turns into a kind of spiral of product development, where you're improving product and coming up with new things to build based on how things went with your last iteration. So when I talk about the QA industry and the responsibilities that the QA industry has in terms of the software development cycle, we're mostly talking about this stage here, the stage of testing the applications. That's traditionally what we think of when we talk about quality assurance or quality control. It's just making sure that things that don't work don't get in the hands of users to give them bad experiences. In a very modern software development team, the role and responsibilities of QA folks is going to be much broader than simply receiving an app build and testing it to make sure it works. And it will, probably span into all of these other stages as well. But the kind of very simplistic way of thinking about it is that the testing stage of the cycle is kind of owned by a QA team or someone on a team who's thinking about things from the perspective of the quality of the application. So the two kind of main types of QA that we find out there nowadays are what we now call manual QA, which is the way that things always used to be tested, which is just essentially hiring people to take new versions of an app that are beta versions or pre-release versions, one way or the other, and just use that application the way they would if they were a user receiving the application as an official release, and then walking through a variety of predetermined user flows or creatively exploring the app, looking for things that don't appear to work right. So that's what we call manual QA. And it was the kind of traditional form of QA for some time. And then eventually there was enough pressure for increasing the speed and efficiency of the software development cycle that we had to find new methods for checking the quality of our applications. And so what's become kind of the standard practice for checking the quality of an application nowadays is what we would call automated testing or automated QA that involves actually writing code to test the code that is running in your application. So this can take place at a lot of different levels. If you have a software development background, you've certainly written unit tests in the past that act at the level of individual code units. But we can write automated tests at basically any level you can think of, including sort of the highest level out from the application, meaning the UI of the application itself. So we can actually write automated tests that completely mimic the way that a user would use an app, finding elements and tapping on buttons as if there were a person sitting outside of the application using their eyes and their brain to navigate through the various screens of an app. So these are the two types of QA. Everything that we're talking about today basically goes in the bucket of automated QA. That's where the industry is at. I develop tools for the purpose of facilitating automated QA. And when people are talking about applying AI and machine learning to the QA industry, they're usually talking about processes and machine learning methods that assist with automated QA or maybe even replace automated QA. But when it comes to AI and machine learning, no one is really kind of applying that to the manual QA mode, which is necessarily becoming a little bit more obsolete due to the requirements of speed and efficiency and scale in the software development cycle that we now have. So what is the question that we're really talking about today when it comes to AI and machine learning in the QA industry? I think this picture is a good illustration of the question that I want to ask. If I were in front of you all in a live room somewhere, I'd have removed this logo from the picture and asked anybody what they think this is. Because at first glance, it's a little bit hard to tell that this is a toothbrush that is being promoted as involving artificial intelligence somehow. When I first saw this image, I think I laughed out loud and said a big nope, because the last thing I think I want inside of my teeth is artificial intelligence, but maybe I'm alone in that. Clearly, the manufacturers of this particular toothbrush think that they're selling people something that they want. A little bit unclear to me what that is. But this is, I think, a kind of example of how maybe even just in marketing, but how in general, I think we can go a little bit overboard in thinking about how AI is applied to actual problems that we want to solve. So a natural question is, applied to any given industry, is AI actually equivalent to BS for that particular industry? It seems like for the toothbrush industry, it's unclear what it means when people say that AI is actually applied to that particular problem of brushing teeth. People have written about this. I found a quote that I really like. It says it's talking about something that the author calls a BS industrial complex. And I'll leave you a moment to kind of work out what that might mean based on this quote. But the quote is, the core feature of this BS industrial complex is that every member of the ecosystem knows about the charade, but is incentivized to keep shoveling. And shoveling what, you might ask? Well, the BS, obviously. So I think the idea, going back to this picture, is that I think everybody who sees this marketing and everybody involved in creating this bit of marketing knows that what we mean by artificial intelligence here is, a little bit fake. But once we've started using terms like AI to refer to basically anything that we want, it becomes a kind of table stakes for marketing. And so now it's like, if you don't have AI in your product, you're somehow late to the game or not at the table. So you have to say that your product involves AI, whether it really does or not. And at the same time, all customers and recipients of this marketing know that, yeah, they're saying they have AI, but that may or may not mean anything. So that's what this quote, I think, gets at, that everyone knows about the charade, but is incentivized to keep shoveling, because if you don't sprinkle some AI on whatever it is you have, then you're kind of left in the dust from a marketing perspective. Another set of images that you've probably seen when it comes to AI is this one. The idea behind this meme is that a lot of what people promote as AI is really just kind of software development under the hood. It's not actually anything different than what we've had for years in coming up with algorithmic solutions to problems. So hand coded solutions to problems that simply use regular old software development practices. So in this case, they're just saying there's a bunch of if else statements that lead from a problem to a solution. And so people kind of make fun of unmasking different bits of software that are marketed as AI as, well, just the same kind of software that we had before. And I think this is often the case, and we'll see some examples of that. But obviously, if there weren't something that was called AI, we wouldn't be marketing it as something different. So what is AI, and how is it different from any other software technology, and what got us to this place of marketing it in this kind of intense way? So let's do a little brief digression into kind of giving a definition of AI and machine learning, and some examples, getting into some specifics. And again, apologies if this is kind of a overly simplistic overview for some of you who may know more about this than me, but this is, as I did a bunch of research, tried to come up with some simple definitions here. At a first glance, you could give a definition of artificial intelligence as anything a computer does that seems smart, seems like, oh, that's the kind of thing that only an intelligent agent or only a person could previously have done. We could define artificial intelligence that way, but it's actually not a very helpful definition, because computers were already doing things that seemed smart, even when we knew that there was nothing particularly intelligent about them, even when we knew that it's just human beings writing a bunch of if-else statements, and computers can perform tasks that used to require human intelligence, calculations, all kinds of different programmatic solutions to problems, things like that. So this is a definition that I think ends up being what's actually used, but it's not a precise definition. It's not really helpful for us in determining whether a given tool or product actually involves AI or not. So, we could also talk about machine learning, which tends to, I think, be susceptible to more specific and better definitions than AI does, which is this very generic term. This person named Arthur Samuel once defined machine learning as the field of study that gives computers the ability to learn without being explicitly programmed. And I think this is a much more interesting definition because it specifies uh, something that I think is intuitive, and it puts it into words. This phrase, without being explicitly programmed, and the phrase "learn." I think this gets at kind of the core goal of machine learning and AI, which is to have computers do things that are novel that we didn't explicitly instruct them how to do. So, that's why the meme of the unmasking of the if else algorithms is funny, because we naturally assume that when we talk about AI and machine learning, we are giving the computer somehow the ability to do things that we're not telling it explicitly how to do. We're not teaching it explicitly how to do. So this definition of the ability to learn without being explicitly programmed, I think, gets at that very well. So what are ways that we could teach computers to learn without being explicitly programmed? Let's talk about a few of the kind of main subcategories of machine learning to give you some ideas about that. There's a category of machine learning that we call supervised learning, which basically just teaches a computer to learn a function. By function, I just mean given an input, what's the output that corresponds to that input, based on a bunch of inputs that we already know the output to. That's what we mean by tagged inputs there. There's something called unsupervised learning, where instead of having a bunch of predetermined answers for the questions in a data set that we want the machine learning model to learn, we give the machine learning process a bunch of kind of unclassified data and ask for it to figure out where the kind of natural differences are between characteristics or attributes or qualities of that data, so that it could potentially learn groupings of data without us explicitly giving it any examples of groups to begin with. There's something called reinforcement learning, which is a sort of different method of machine learning that can come up with similar results. But it's more about giving a kind of scenario that the machine learning model can act in. So give the machine learning model a kind of world that it lives in, and give it the ability to do certain actions within that world, and then have it take random actions in a sort of trial and error way, but reward some actions and some outcomes of those actions within the virtual world of the model more strongly than others, to kind of reinforce or teach the model what sorts of actions and outcomes lead to the situation that we want, in a very similar model as to how actual human people learn and grow by, as I've seen my toddler do, trying random things and then seeing what happens. And we reinforce certain behaviors and things like that, and that's how people learn to do things in the world. So this is a similar way of trying to teach computers by constructing a world for them to act in. And then a sort of other category that people talk about, which isn't really a sort of different overall technique. It's more of a different set of methods here, is called deep learning. And again, it's not really its own category of machine learning. It's more of a specific take on the use of a particular machine learning method known as a neural network. So we'll talk a little bit about that as well. So what are some examples of these things? For supervised learning, we could use it to, let's say, classify a new instance of data based on a model of data that's already existing. So we have a bunch of data points that we know are true, and then we could give the model a new input, and it would tell us what the output is, whether that output is a category or a numeric value or something like that. Example of what we might use with unsupervised learning would be to find patterns in a data set that's a very big data set that has a lot of attributes, and we're interested in finding natural groupings of that data, but it's hard to do that by hand. So we could feed all that into an unsupervised learning model and have it come back to us and say, oh, here's there are basically 3 types of data points, and here they are in a categorized way. With reinforcement learning, we might enable a software program to develop human-like reasoning in some kind of task environment that's well-defined enough for reinforcement learning to really work. And some of the use cases for deep learning would be to attack problems with input data that's so complex that traditional methods, traditional neural networks might not be able to come up with a good answer for us. Some more concrete examples, supervised learning, this is a kind of beginner's project with a lot of machine learning courses, uh, create a model such that you get some information about a flower's characteristics and you use that to predict the species of a flower. With unsupervised learning, we could, write a model that would take in a huge library of popular music, use it to find kind of natural groupings of songs based on, characteristics that we might or might not think about. And then we could see whether those groupings of songs actually correspond maybe to what we consider genre to be. And that would be an interesting project. With reinforcement learning, we could use it to teach a bot to compete against humans in a video game, as has been done quite popularly with games like StarCraft or board games, things like that. An example of what we could do with deep learning would be maybe to classify the species of an animal just according to an image of an animal. And obviously an image of an animal doesn't directly involve features of an animal. It directly involves features about pixel data and brightness and color and things like that. So to turn that into a classification of an animal species is a really interesting, complex problem that's suited for deep learning approaches. So just to put up some examples of some algorithms that are involved that you might hear about with some of these approaches. With supervised learning, one of the simplest algorithms you might put into practice would be something called linear regression. We've got clustering methods like k-means clustering. I'm going to kind of skip over this really quickly because I think I want to leave some good time for questions, and some of these I think are just a little specific. One of the more interesting things that you could look up if you haven't already is discussions about generative adversarial networks, which are kind of the algorithms and ideas behind deep fakes, which have been in the news quite a bit, and which have real, I think, consequences for how we're navigating different questions in society. But from a technical perspective, basically the idea behind these generative adversarial networks, also called GANs, is that you don't have just one neural network that's constructing kind of fake data based on real inputs. Instead, you have two of them that work in a kind of imitation game against one another. So you get this sort of spiral of quality of the fake output that you're producing, until at some point the neural network that's producing fake output is producing fake output that's so good that the neural network that's responsible for deciding whether it's fake or not believes that it's true. And at that point, it's often high quality enough fake data that human beings struggle to tell whether it's fake or not as well. So some really interesting stuff here that you can certainly look into. Here's an example of what a linear regression model might look like. Taking a bunch of data points in 2 dimensions. Here we're crossing income with years of post-secondary education, and this dotted line that we're drawing is essentially the construction of a supervised learning model. So now that we have this line, which is nothing more than a formula, we can take new values of income and predict new values of years of post-secondary education. So that's a kind of a very, very simple but oftentimes very successful machine learning method. Here's an example of what the stages of a k-means clustering algorithm might look like, where you start out with these natural groupings of data, and you want the computer to sort of figure out how to separate them in such a way that, given a new data point, you would know which cluster or which group it belonged to. So this is a kind of pictorial representation of how that algorithm moves kind of centers of gravity around so that it correctly sorts the various inputs, and now can predict, based on its final state, the categorization of new inputs that you might give to the system. And here's an image that shows an example of a deep learning neural network in process, where you've got these multiple hidden layers to the network that, because of the different levels here, can actually retain a lot of information from the training process. So you get really surprising abilities to give labels for things like animal species according to an input image. And this last picture here is an example of generative adversarial networks at work. So on the left-hand side, you've got a bunch of output from the network, and on the right column of each of these are actual real instances of numbers or faces, as the case might be. So those are actual pictures of faces or actual numbers that people drew, and all the other ones are kind of creations of the network. So you can see that for the most part, they could fool you into thinking that, you know, a real person might have drawn one of those numbers, or you know, the picture might be of a real person. You can also tell, especially with the pictures, there's some weird things going on, and some of them don't seem quite real, but at a first glance, they do. Okay, so given that kind of slight deep, you know, slight dive, not deep dive, we'll call it a shallow dive into AI and machine learning. Let's apply that kind of thinking to what we see in some of the marketing in the QA industry about machine learning. So I'm just going to go through a bunch of screenshots that I took of different tools and products in the QA industry that promote AI in some way or another. So this company is promoting something called visual AI. They think that it provides something called intelligent testing, using incredibly accurate visual AI. So that's interesting. Unsure exactly what that means or what that could be. Here we have a company that's promoting codeless Selenium. Selenium is just a tool for automating web applications. So they're trying to convince us that we could have automated tests that we didn't have to write code for, using AI maintenance. It's a little bit unclear what AI maintenance means. Maybe they mean that rather than having to update tests ourselves when our app changes, maybe AI will somehow magically know how to update our tests to work with new versions of the app. A little bit unclear. Here we have a company that's promoting something called autonomous testing. Presumably, by autonomous testing, they mean testing processes that humans don't have to be involved in. So it appears to be different from automated testing, because automated testing, humans are involved in the construction of the test themselves, even if they're not involved in manually walking through test steps. They're claiming that their product removes something called test churn, increases accuracy and efficiency of testers, you know, but without saying exactly how that happens, just that the AI is used in this process somehow. This company is a little bit more verbose in their description of how artificial intelligence is used in their product. They've defined certain levels, level 0 to level 5 of automation, where levels 3 through 5, they're saying, involve machine learning to some degree. This is kind of helpful because they're, I think, being a little bit more specific about the role of machine learning as it relates to their product. They're saying that level 3 involves human created scripts, but machine learning involved to cause these scripts to be self-healing, whatever that means. Self-healing, I guess, meaning that if the script were to break, it would be fixed automatically. Level 4 is has the subheading of near full automation, auto-generated smart scripts. So that sounds something like test scripts that aren't developed by people, that are developed automatically by a machine learning model. And then level 5, which they call a game changer, involves mined off auto-generated smart scripts with validation. So a little unclear how this differs from level 4 and level 5. I guess with level 5, our minds can be completely off. Sounds a little bit dangerous to me to turn your mind completely off, but there we have it. I guess with this company, we get level 5 autonomy, scriptless testing, and so on. So interesting. If that works, that could be really interesting. This AI can generate real tests 100,000 times faster than humans. Wow. Okay, we have another screenshot. This company uses artificial intelligence to speed up the authoring, execution, and maintenance of automated tests. Okay, curious how that would work. And here's another company that gives app teams the power of AI. Okay, curious what power that would be exactly. I don't think of AI as a power so much as a set of tools and practices. And finally, here's something that's a little more clear, at least in my mind. This company has these AI agents apparently that learns the Google News app on iOS. Oh, okay. So that seems like maybe we're involved in some kind of reinforcement learning paradigm where there's like a bot that's learning how to use an app on its own. So that's a thing that could happen, I suppose. And here's another screenshot of another application. It's actually the HeadSpin product, where you can see here, it's actually pretty difficult to see, but if I zoom in here, maybe I can't zoom in. Anyway, there's this little timeline element called video quality MOS. That stands for mean opinion score. And you can see that there's this line that kind of goes up and down, and that's sharing with us the video quality in a video that's being played in an application that was captured by HeadSpin. And I happen to know that this line is generated by a machine learning model that looks at the video and tries to determine the quality of the video without using any human input. So there's the use of a machine learning model that has been trained on videos and can determine the quality of a video now just by it being played on the screen of a mobile device, which obviously is a valuable thing. If your mobile app that you want to test plays video and you want to figure out is the video being played at a reasonable level of quality or not. So that involves machine learning under the hood. That's a bit of a different type of thing than we've seen so far. So with all these examples, I think we can put together a few categories of what are called AI solutions in the QA industry. There's one category that I basically would call AI and marketing only. And as I've dug into some of these different products and looked at it, it appears that what's going on with a number of these is that rather than the use of machine learning models, in some cases, what we have is simply a bunch of intelligently designed software, software that looks at inputs and using predetermined flows or algorithms that were kind of coded by a developer somewhere, does something important and useful with an automated test script of some kind. So again, this kind of software would be highly useful and worth paying money for, but doesn't involve machine learning models. And so I would call kind of AI and marketing only, maybe similarly to the toothbrush. Then I think there are some products that we can see that I would say use AI and machine learning in a supporting role, where there are machine learning models that are involved and they're used to support various aspects of the automated test process. They're not used as a replacement for actual human authoring of test scripts. So this would be something like the self-healing scripts or the video mean opinion score, things like that, where you have these machine learning models that give a kind of support to the human test author so that they don't have to necessarily do as much work. But there's still, at the end of the day, a human being that's writing test cases and running them in an automated fashion to make sure that the app quality stays high. And then there's a kind of the third type of solution where you see that AI and machine learning is kind of the primary driver of automation. So taking over the reins from the human test author and taking the responsibility of coming up with test cases and running through test cases on its own. In this case, the main idea is that tests would be written and hopefully bugs found by autonomous bots that aren't kind of specifically directed by human beings. And then they act on some kind of machine learning model that's already been trained on a bunch of applications and is then applied to your particular application and hopefully responds or generates some kind of quality report for your application. There are a few products out there that do this, and that's what I think we would call sort of real AI or a real use of machine learning models as the primary driver of automation. So examples of each of these, a product that would be AI and marketing only would be a product that, let's say, looks at user activity logs from your production application and uses those to generate test cases, kind of with the insight that if you can figure out what your users are trying to do in your application, and if you can record those user flows and user steps, you can turn those into test cases that can then be automatically run by automated tools in the future. And that will help prevent regressions for user flows that you know are actually in existence in your actual production application. And that's something that you can do without using AI at all in the sense of machine learning models. It's something you can do simply by intelligently using software to scrape logs and generate test automation code from those. Examples of something with AI and machine learning in a supporting role would be maybe image recognition models used to detect visual differences between two instances of the same test case run at different times or run on different devices or something like that. So it kind of gives you a nice visual indication or warning about potential issues with the visual display of your application screens in different environments. So using machine learning models to kind of detect the level of difference between two different screens. Or as I mentioned, the video quality models that give feedback on user perceived quality of a video that's playing on a screen. And in the last kind of level or category, an example would be a situation where you have your application that you've built. Let's say it's a mobile app bundle, and you send it off to this AI system, and its bots are turned loose on your app, and it generates a kind of report of screens that worked and screens that didn't and issues that it found. That would be kind of an example of a product that uses AI machine learning as the primary driver of automation. So where are we at with our question that we asked? Is AI equivalent to BS in the test automation industry? I would say more or less yes, if we just go by where most of these products fall in the list of categories I said before. Most of them tend to fall in the very top side of the list where it's kind of AI and marketing only, with a few exceptions. There are products out there that genuinely use robustly trained machine learning models, either as a support or in some cases as the primary driver of automation. And those are really interesting tools and products that I think we'll continue to develop and we'll continue to see more like that. But for now, I think most of what we see that talks about AI is kind of AI in marketing only in this particular industry. But a follow-on question to this is, do we actually need AI in our automated testing? Just because something is marketed to us as having AI in it, does that mean that we actually need it? Does that mean that it's actually any better? My position tends to be that we should evaluate technologies based on whatever their actual return on investment is, whatever they actually propose that they can do for us, not whether or not they involve AI. So I think a lot of these tools that we saw screenshots of are genuinely useful things. And the fact that they feel obliged to market themselves as involving AI is sort of unfortunate, because in my mind, it takes away in some ways from the actual value, actual ROI of the product, where if they just told us specifically what they did and what they proposed to do for us, even without the use of the word AI, I think it might be a little more clear whether there was something valuable there for us. And there is a lot of valuable software that doesn't involve AI at all. So whether something involves AI or not is kind of irrelevant to us. What's relevant is just what can a particular technology do for us, and we need to be skilled at evaluating that question, not evaluating how well something matches, a hype term. So, I mean, if you ever find yourself in the position, I suppose, of trying to evaluate some of these technologies that seem a little bit vaguely presented, or just declare that they involve AI without any more specific details, obviously we could use our knowledge of AI and ask a kind of educated question like, oh, you propose to do this with your product, what corpus did you use to train your machine learning model on? And obviously if the answer comes back as, oh, we didn't, or, oh, we have no idea what we're talking about, probably, they're not really using any interesting machine learning technology or approaches under the hood. And probably it's something more like AI in marketing only. So, my prediction based on the products that I see right now is that most actual value that we're going to be getting from AI and machine learning in this industry is going to be the category of AI and machine learning in supporting roles, which I think it makes a lot of sense because um, for a while yet anyway, I think the technology is not quite there to take over the job of deciding what a good test case is, deciding what user flows are important to automate, and deciding what counts as a bug or what doesn't count as a bug, things like that. But there's an awful lot of difficult problems out there that I think machine learning could help with in a supporting type of role. And the examples that we gave of very reliably telling us when two different test runs generate visual screens that look different, and that might be a problem, or the little feature of telling us, oh, you were running a test of this application and it played a video, and at this point in the video the quality got really bad. That's a really interesting bit of information that gives us a lot of value, and that value comes from the value of the machine learning model that was trained on video to provide that kind of output. So that's kind of my thought about the state of AI and machine learning in the QA industry. Hope that was interesting. Granted, many of you may not be involved directly in the QA industry, but hopefully it was an interesting glance at what's going on in this particular world. And again, want to just share that if you are interested in the QA industry, if you're interested in learning more about test automation, maybe even learning how to write automated tests yourself, if that's something you're interested in as a potential career move, that's kind of our job at HeadSpin University, is to help people go from not really knowing too much about automated testing and being proficient in it. So you could check us out at HeadSpin University. If you want, you can also check out my blog and newsletter, appiumpro.com. Some interesting stuff there to do with mobile automation specifically. And just because I think it'd be fun to do this, if anyone is actually interested in learning about mobile and web app automation, I just released a course called Appium and Selenium Fundamentals. And I'm really excited about this course and really want to get more people involved with it. So if you email me at the email shown here, first 5 people to do that, I'll give you free access to this course, and you can learn all about test automation, what is testing, web testing, mobile testing, how to build robust test suites, how to write code in the Python programming language. There's a whole bunch of stuff included in this course. So yeah, first 5 people that email me there, I'll give you free access to the course, which is just coming out of beta at the moment. So that's it for me talking. I know that I've used up probably more of the time than I intended to, but happy to stick around for a bit and answer some questions. So Sharon, if you've seen any interesting questions pop up, or however you want to arrange the Q&A time, let's do that.
That was great. Thank you, Jonathan. Yeah, so we'll move into the Q&A session. We'll start with the ones that came in during the session, but if you have any other questions, feel free to drop them in the chat below. So the first question is, sorry, I came late, but I know you mentioned categories of AI solutions, but are there different categories of AI? Also, what do deepfakes fall under?
Right, so yeah, so deepfakes, might have missed this part, but deepfakes are a result of something called generative adversarial networks, which is basically a very interesting technique involving the use of two neural networks to play a sort of game with each other, where the job of one network is to produce novel items in according to whatever types of things it's been trained on, and the job of the other neural network is to decide whether the item produced by the first network is real or fake. And so obviously it starts out where everything that's being produced is going to be very easily detectable as a fake. But then the first model kind of learns from that and keeps trying new things until it gets better and better at producing fake data, until at some point the second model can't detect that it's fake anymore, and we have a candidate that's then used. So when it comes to generating deep fakes of images or handwriting, like we saw, that's pretty straightforward. When it comes to video, I imagine that what happens is you have a reference actor, and then each frame of that is treated as an input image to the deep fake, to the generative adversarial network, and that results in like a new video. So strikes me that would take an awful lot of processing time and power, but I haven't dug into that specifically, so someone else might know more about that here.
Fantastic. Okay, and the next question was, to what extent do you predict that AI will be replacing jobs, tasks, or changing roles in the QA industry or other industries, or is this an overstated fear?
That's a good question. I think people land all over the board with answers to this question. I haven't seen all that much that makes me think that QA roles are going to be replaced anytime soon with completely autonomous, AI-driven bots. There are some interesting products out there that are aiming to do this, and they're making progress, and so we'll see how that goes. But I think that by far the biggest shift in the QA industry is going to come just from automation. There's still a lot of manual QA out there that's going to get replaced by automation, and obviously, the fact of automation implies the reduction of roles, because one person writing automation can accomplish more testing at the end of the day than a number of people who are testing manually. So that's going to be still, I think, for a while, the bigger type of change that we see. But then, down the line, there may very well be similar changes that occur as a result of AI. But I would say that typically what I've seen with AI is not that it completely replaces jobs, but that it turns the role of humans into something that's more like a training role or a guiding role or a labeling role, rather than the role of actually driving things. So we might just see a kind of shift of responsibilities there. It could come with a reduction in the number of roles that are available too. So, I mean, obviously, whether or not you think AI is going to replace, automated testers, it's a good idea to familiarize yourself with AI, because at some point, you'll likely be using AI tools, even if they're not completely replacing testers as roles.
Great. And this was answered live in the Q&A, but I'm just gonna repeat it. If I've been in QA for a while, how can I contact you?
Oh, well, I suppose it all depends on why you want to contact me. But yeah, Shuchi put my email there. Depending on what your question is, I'm happy to help. So feel free to send me a note.
Great. And how do you write automation to AI/ML, which is black box, and your expected results are just if statement?
Yeah, I'm not quite sure what that question means. Maybe I answer it by saying there are different ways that machine learning can be involved in the test automation process. We have machine learning in a kind of supporting role. There are some products out there that, for example, you write your test or you record your test using a kind of test recorder, and then that test is run. And then if the test runs into problems, then there are mechanisms that try and fix those problems on the fly, either using actual machine learning or just using a bunch of if-else statements, right? So an example of the if-else statement approach, or just the algorithmic approach, would be, let's say you've written a test that involves the use of a certain element ID or selector, and your test is in the process of running, and the test would fail because that element couldn't be found. An algorithmic approach could say, okay, well, last time we found this element, it could also have been found using a number of other selectors. So let's try some of those right now. And if it can find the element by some of those other selectors, then the test proceeds as planned, and maybe the code is even updated or the database is updated to prefer that new selector in the future. And that's often the kind of approach that's taken with test scripts that are called self-healing. But then, yeah, in the other kind of category where machine learning is being used to drive the test in general, you don't do anything to write automation. You just give it your app, and it uses your app and generates a report for you about what worked and what didn't work. And you hope that it found everything that didn't work, and you hope that it understands your app well enough. And that's kind of one of the areas of limitation right now, where I think that oftentimes an actual human being understands the purpose and intent of the application in such a way that they're the only ones that are qualified to say what counts as appropriate behavior for the app and what counts as inappropriate or failed behavior or a bug.
All right, and one last question. Have you seen a shift from DOM-based automated test writing to visual component-based automated test writing? Do you have a strong opinion on one versus the other?
Yeah, I have seen more people that choose to sort of prefer visual tests over DOM-based tests or element hierarchy-based tests. Do I have a preference? I think it depends on how explicit you want to be in what you're testing. I think if you want to be really explicit about what you're testing, then the DOM-based approach is valuable and gives you, if it fails, it gives you kind of a specific area to look for the problem. I think one of the value propositions of visual testing is that all you need to do is take a screenshot and then check for differences from something that you knew to be working well. And one visual check can actually catch, any number of bugs, right? So if you've got 15 elements on a screen that you would need to check sort of one after the other using a DOM-based approach, you could check all in one go using a visual approach. The only problem is if something fails, if there's a visual regression, you don't necessarily know what caused the failure. You have to go and look at it yourself. Whereas with the DOM-based approach, if something fails, you have the line of code right there that caused the failure, and oh, it was this particular element that has the problem, and you don't necessarily need to go and look at it. On the other hand, if something fails, it's usually involves a manual investigation anyway. So oftentimes just looking at an image of the screen and seeing what's been highlighted as a visual difference is enough for you to say, oh, I know where the problem is now. So yeah, pros and cons to both.
All right, looks like that's all the questions we have for today. Thank you for the questions. If you come up with questions later on, feel free to reach out to any of us afterwards. And I just want to thank everyone for joining. There will be a recording that we will send out, and that will also be available on both headspin.io and womeninbigdata.org. And special thanks to Jonathan again for providing us with this great presentation discussion. Thank you. Have a great rest of the day, everyone.
Welcome.
Thank you.
Bye, everybody.
Bye.